All right, this is your pre-lab video for your your first kind of chemical reaction lab. But this is going to look at how different ions potentially can form new substances. So the purpose of this lab is you're going to have a mixture of substances, and based on those substances being mixed, you should see a color change. Okay, color change is one of the indicators that a new product has been formed. So a chemical reaction is being formed, or a chemical reaction has occurred. Okay, and usually that's due to um, uh, a wide variety of different probabilities, but the color change is an indicator that a chemical reaction has occurred. So your objective or your purpose is to plan and carry out an investigation to determine if different ions of the same element react differently in similar circumstances. Okay, so you're probably wondering, well, what does that mean? How can different ions, or how can there be different ions of the same element, right? Well, remember, for the non-main group elements, such as transition metals, they have the ability to form multiple ions. Okay, so when you look at, say, the ions that we're going to look at the iron 2 ion and the iron 3 ion. So iron 2 means it's an iron 2 plus ion, and iron 3 means it's an iron 3 plus ion. So both of the ions are of iron. They're both the same element. However, they have different charges. And what you're going to do is you're going to determine through a series of reactions whether or not the charge of a transition metal is going to matter. Okay. Now, this lab is going to need a hypothesis, right? So this is going to be an if-then statement, and that if-then statement needs to be testable by your procedure. And if you notice, it says your procedure. You are going to write this procedure out. Okay, I'm going to give you all the materials. I'm going to let you know what you have available to you, but you're going to have to write the procedure. Now, as far as your hypothesis is concerned, it may be necessary to redo your hypothesis a few times when you're deciding what the steps of your procedure are going to be. And the reason why you may have to do that is because you don't want to make a procedure for, you don't want to collect data that doesn't even test your hypothesis, or you don't want to make a procedure that doesn't test your hypothesis. Okay, nothing's worse than doing a whole lab and then go, wow, this data has nothing to do with rejecting or not rejecting my hypothesis. Okay, so this may take a while. So be prepared. If this, some of you may be working on the procedure the whole day tomorrow. And if that's the case, that's the case. So, um, like I said, though, I'll give you little nuggets when you need them, but for the most part, this is going to be your procedure, and it needs to reflect your hypothesis and be able to test your hypothesis. All right, so the safety here. You are not to begin, this is, status quo. Don't begin any work with chemicals unless they've been approved by me. Well, I know which chemicals you're going to be using, but I want to make sure that you're not going to start without me knowing that you started. Okay? You need to always have your goggles on. Okay? If you do not have your goggles on, or if you don't have your goggles on and somebody else is at the bench on the other side for somebody else's group doing the lab and you don't have your goggles on, I'm going to kick you out of the lab. Okay? If you are in the lab and labs are going on, you have goggles on. Also, wear closed-toed shoes right here. Okay? If you don't have closed-toed shoes, I'm not going to allow you to do the lab. I will not even let you make it up. I'm just going to give you a 0. Okay? Make sure you bring closed-toed shoes. The reason why is some of the chemicals that we're going to be talking about, they will burn your little piggies down there and you won't be happy. Okay, you'll probably be in some pain. So make sure that we bring closed-toed shoes. If that means you have to just bring them with you and then um, you're just wearing them for this period, that wouldn't be the first time that's happened. So make sure you bring closed-toed shoes. If not, right, you forget them, you're more than welcome to borrow a pair of my closed-toed shoes. But unless you are a women's size 9 or a men's size 12, you're probably going to be fairly uncomfortable, not to mention that you're wearing somebody else's shoes. Okay? Make sure you don't touch, inhale, eat, or drink any of the chemicals or inhale the fumes for obvious reasons. One of the chemicals is very, very, very painful to take a big whiff of, so I would recommend that you not do that, and I'll tell you in class the difference between wafting and the difference between smelling. All right, and lastly, make sure you wash your hands when you're done with the lab. If that means you have to go to the bathroom to wash your hands, then so be it. Not a big deal. These are your available materials. So we're gonna have one 12 well plate, which is this guy right here. There's 12 wells here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and I've kind of given you a bird's eye view with this diagram right here next, and I'll show you what you're doing with that. Now, you're going to have some dropper pipettes, and each one is going to be in with some chemicals. Now, my advice to you is if you want to actually complete the lab and not mess it up for everyone, you need to make sure that the droppers that are in the solution, so for example, the solution 1 dropper stays in the solution 1 container. Okay, if you mix up the solutions or you mix up the pipettes, you're going to ruin it. If you can't remember which pipette it went into, just ask me and I'll get you a new pipette. If you put the wrong combination in here, it's going to ruin the lab for everyone. We have to redo solutions. It's going to cost us a day to fix it. Okay, and not to mention you're going to be on my bad side. Okay, so you got to make sure that if you don't remember what dropper it is, it's not a big deal. I have plenty of pipettes. We can just put them in there as we need to, but we do not want to mix them up. Right? The solutions that you have. Okay, I'm going to make a little change right here. It says that you have 7, and you are going to have 7, but you're not going to test all 7. So solution 1 is your iron 2 source. You are going to use that. Okay. Solution 2 is an iron 3 cation source. You are going to use that. Solution 3 is distilled water. Okay. You are going to use that. Hopefully we can decide, or you can figure out between you and your partners why we're needing to use that. Now, for the remaining 4, you only have to choose 3 of them. Okay, I'll let you choose whichever ones you want. Okay, but there should be 3 of these being used. Okay, you need to use 3 of them. All right, so 3 of the 4. So if I was to get my bird's eye view, right, which is right here, where are we going? Okay, you're going to have 12 wells. Okay, you're only going to be using you're only going to be using 8 of them. Okay, I'll let you organize how you're going to do it. Okay, if I were you, I would draw this because this would be a good thing to have in your comp book or on your, in your groups when you guys are doing this lab. Okay, it may help as a graphic organizer and deciding your procedure. Okay. Also, one thing that you're definitely going to need to do is I want you to have a piece of white paper. And the reason why is because we are looking at color change, and these things are clear. So if you put a white piece of paper underneath this clear well tray, then or this well plate, then you'll be able to see the colors a lot clearer. Okay, the black countertop of the lab bench doesn't provide very good contrast. Okay, so let's go ahead and scroll down a little bit. So you and your group is to devise a procedure for this lab, and it should begin with a list of your group members' assignments. Okay, and I'll go over the assignments here in a second. All right, it needs to have the period, the date, list of materials, and your hypothesis. And this should be written in your composition book. If you don't have your composition book, make sure you have it on a piece of paper. Okay, the procedure must be written out and signed by me before you can begin this work. Okay, if you try to submit a lab that doesn't have these signatures, you'll get a 0. Okay, group roles should be assigned and clearly identified in this lab report, as I mentioned. Okay, an individual may have more than one group. Okay, I'm going to go ahead and skip down to our different assignments here. So the project director, right? The director is responsible for the groups and will be the spokesperson for the group. Okay, that's not a typo. You're going to be a spokesperson. You're going to direct, make sure you have, you're going to have pretty much the plan. Okay, you're going to direct group members to their jobs, keep them on task. Okay, and you're the only group member that's allowed to talk to me if you have questions. Okay, I don't want to talk to 15 different people. Now, the exception to this, of course, is if there's a safety issue, right? If you're accidentally broke glass and it fell on your foot and you happen to wear shorts and it cut your leg, you don't need to go have the project director come talk to me that you need to go to the bathroom or you need to go to the nurse office. Just let me know and we'll make sure you get there. Okay. Also, if you happen to be the project director, you are going to be responsible for sharing a summary of the group results with the class. You are going to present this data. Okay. Next, we have a technician, and there may be more than one of them. You're responsible for obtaining the necessary materials and or equipment for the lab and enforcing the safety rules when conducting the lab. Okay, I'm not going to go over everything that they need to do. Just go ahead and pause the video. You can read through it. Okay, lastly, we have the data collector. You're going to be the recorder. You're going to have the data table. You're going to have the graph. Okay, everything is going to be in with in your writing initially. Okay. So make sure we have clear notes, because you're going to have to communicate that with the rest of your group, because you're all going to have to come together to make one report. And as it says right here, you are going to have only one report to do. It's going to be one report to turn in for your group member. So, okay, it should follow the chemistry lab exercise. And it's going to be presented in front of the class. And when I say presented, it's not going to be a full 20-minute presentation. It's probably just to be a quick 5-minute presentation to discuss your procedure and discuss your results and what your results mean. Okay. Now the exact contents of your lab report will be discussed at a later date. Okay. Make sure that and that's a little typo right there. There should be one space right there, because they talked about what the group roles are. So yeah, make sure that you have just a little check mark, or a little check of what you need to make sure you have done. Okay. You need to come in tomorrow and hopefully have an idea of who you want to be groups with. Okay. And you're going to start working on your procedure and your hypothesis. If you don't get to start the lab tomorrow, then you don't get to start the lab tomorrow. All right, it's more important that you have a good hypothesis and a good procedure that can test that hypothesis. Okay, but you're not going to have an infinite amount of time. So hopefully your goal is to have your hypothesis, have all your group assignments in, and or your group assignments. So who's going to be the director, who's going to be the technician, and there may be more than one, and who's going to be the recorder. Okay, and you're going to have a procedure down, and that procedure needs to be seen by me. Okay. I'm not going to look at any procedures after the beginning of the second day of this lab. In this case, would be the day after the first day, which is tomorrow. Okay? If you have any questions, by all means, send me an email.